All right, good morning. Today we're going to start chapter 3. It's day 15. We're halfway done with the semester after today. And fortunately for us, now we start doing the fun stuff because in this chapter, we start expanding away from linear equations. We start dealing with what are called quadratic equations. And then that builds us up to polynomials, which builds us up to the next chapter, which deals with all polynomials. And then we end the semester up with logarithms and systems of equations. So now we're in the fun part of math, if there is a fun part of math. So the first thing we're going to talk about, complex numbers. What are complex numbers? Well, we have two types of numbers that we can deal with. Up until now, we've dealt with what are called real numbers. Integers, rationals, radicals, anything that we've done so far are real numbers. The opposite of real numbers are what are called imaginary numbers. These are numbers that you can't graph. You can only imagine what they look like. A primary example, in which we're going to focus on mostly today, is we know what the square root of 4 is. It's what? Yeah, 4 is made up of 2 times 2. Now, the reason it's called a square root, because there is an invisible number there. There's an invisible 2 there. That's called the root. That's why it's called a square root. The root tells us the number of times a number needs to repeat to remove it from the radical. So that's a 2. So once we have 2 of the same number, that's where you get our answer. Likewise, cube root of 8. Eight is made up of 2 times 2 times 2. There's 3 of a kind, so it comes out. So that's what the whole thing's about. The cube root of negative 8. Okay, 8 breaks down to 2 times 4. 4 is 2 times 2. That's where we get the 3 2's. That's called factorization, prime factorization. So if it's negative, negative 2 times negative 2 is positive 4, times negative 2 is negative 8. So the answer is negative 2. But we can't do that, because 2 times 2 does not equal negative 4. Negative 2 times negative 2 does not equal negative 4. So this number cannot be achieved. That's an imaginary number, because it can't. But in the real world, sometimes it does exist. So how do we take care of that? That's what imaginary numbers are all about. So what this says, if your root odd roots can be positive or negative. Even roots can only be positive. Could be a real number. So what do we do with a -4? Square root of -4. Well, first off, remove the negative. Because this number is actually made up of a -1 times 4. And we can split those up. We know the square root of 4 is 2. But what does this equal? I. I is defined as the square root of -1. It removes the negative out of an even root function. Hence, that's why it's called an imaginary number. Imaginary numbers have an I after it. But we still haven't gotten to what we're talking about. How does all this relate to complex numbers? Complex numbers are made up of real numbers plus imaginary numbers. So a complex number looks like this. A plus BI. Every number we can think of can be written in this form, where A is the real number and this number is the imaginary. So a complex is made up of a real and an imaginary number. So let's look at some examples. Tell me if these are complex numbers or not. Okay, the first one. Is it imaginary? I mean, is it a complex number? Yes or no? So we have a no. What do y'all think? Is it a complex number? It's either yes or no. It's 50-50 shot. It is a complex number. Complex number, this is a real number. Real number is all the numbers that we deal with right now. We go from negative infinity to positive infinity and everything in between. If you can graph it, it's a real number. This has an I after it, so it's imaginary. So this is a real plus imaginary. It is a complex number. How about the next one? Yes. The real number is 2. The imaginary is negative 5i. So it is a complex number. How about the next one? Is it a complex number? It is a complex number. Remember, complex numbers have to be in this form. So this is a real number. The I coefficient is just 0, which is 3. Is this a complex number? Yes, it is. It is because the real number is 0, and the imaginary, this is the real, this is imaginary. So every number we have is imaginary. If there's nothing behind it, if it's just a constant, it's got a 0 imaginary number. So because imaginary numbers, okay, you can't graph them because they're imaginary. How would you graph square root of negative 4? You dot right here. You can't graph it on paper. It's impossible. So what can we do with them? The algebra of complex numbers. What this means, whenever you hear the word algebra, all it really means is you can do the binary operations, plus, minus, multiply, and divide. You can do all that to it. Remember, we did all these with functions before, didn't we? We had f of x plus g of x, f of x minus g of x, f of x times g of x, and f of x divided by g of x. We did all that with functions in chapter 2. Okay, if you just saw that, you'd say, yes, those are all true. But what if I defined f of x as 3 plus 2i, and g of x is 5 minus 4i? Because they're functions, those still apply. So we can do the addition, subtraction, multiplication. We do the algebra with complex numbers. Well, let's look at addition. We'll use these examples. We do f of x plus g of x. So we have 3 plus 2i plus 5 minus 4i. It's always a safe practice to, whenever you put functions or numbers inside an equation, put in parentheses. And then we can look at, do we need the first parenthesis? Is there a coefficient in front of it? No. So we could just drop it. And the second one, is there a number in front of it? No. Is there a positive? Yes. So we could just drop the parenthesis. The rule in math is whenever you remove parentheses, always combine like terms. So whenever you get rid of parentheses, the next step should always be combine like terms. So we got rid of parentheses. So let's look at like terms. Here's a real number. 3 plus 5 is 8. Then we have a positive 2i and a negative 4. 4 is bigger than 2 and it's negative, so it's going to be negative. 4 minus 2 is 2i. So there's your answer. It's really no difference than if it was an x. It's really not that much difference. What if we had coefficients in front of our terms? Yeah, we first have to get rid of the parentheses. We can't do anything inside it. Order of operations always is in play. We can't do anything inside the parentheses, so we have to get rid of the parentheses. So we distribute. 2 times 3 is 6. Positive times positive is positive. 2 times 2 is 4. Positive times positive is positive. 3 times 5 is 15. Positive times negative is negative. 3 times 4 is 12i. Got rid of parentheses, so combine like terms. Positive 6, positive 15. They're both positive, so the answer is positive is 21. Positive 4, negative 12. 12 is bigger, so it's negative. 12 minus 4 is 8, and there's your answer. Subtraction. We're going to do f of x minus g of x. So f of x, if we don't use parentheses, remember f of x was 3 plus 2i, and g of x was 5 minus 4i. If I don't use parentheses, do I still have those same functions? No. Positive 3, positive 2, negative 5, negative 4. Positive 3, positive 2, positive 5, negative 4. So this negative, this minus sign, if I don't put parentheses, it changes that next term. That's why we always put parentheses around whenever we put in numbers inside of a function, an equation. Then, since there's nothing in front, we can just drop the parenthesis. But this one has a negative sign. It's actually a -1, to be honest. Then we have to distribute. Negative times positive is negative. 1 times 5 is 5. Negative times negative is positive. 1 times 4 is 4i. So it changes both of the signs. Positive 3, negative 5. The 5 is bigger, so the answer is negative. 5 minus 3 is 2. Positive and positive, they're both positive. 4 plus 2 is 6i. And there's the answer. And what if we had coefficients? We can't do anything inside the parentheses, so we get rid of the parentheses. 2 times 3 is 6. Positive, positive. 2 times 2 is 4. Negative times positive is negative. 3 times 5 is 15. Negative, negative is positive. 3 times 4 is 12. Combine like terms. Positive 6, negative 15. 15 is bigger, so the answer is negative. 15 minus 6 is 9. Negative 9. These are both positive. 12 plus 4 is 16i. And there's your answer. So again, it's very important on where you put parentheses and how you distribute all this stuff. Actually, yeah, if you ever come in late and everything, don't worry about taking pictures of the screen. I'll let you come before class, when class is over, I'll come and let you take pictures of the notes. All right, so now multiplication. Even though we haven't discussed exponents, the rules of them, like in last chapter, whenever we have x times x, what does that equal? We had x times x times x. Because all this stuff tells me how many times does this number multiply to itself. So this is x times x multiplies to itself twice. X times x times x, the same number multiplies to itself 3 times. That's what the exponents tell us. So here, we're going to look at f of x times g of x. F of x was 3 plus 2i, and g of x was 5 minus 4i. Again, this is, they introduce this stuff before they actually introduce it to you. These are called binomials. Bi means two, nomial pretty much means numbers, are terms. 2 terms. That and that. Remember, a term is anything separated by plus or minus or equals. What we have to do here, you guys learned it in FOIL in high school, but it's really distributivity. Everything in the first parenthesis has to multiply to everything in the second. So, the first term, positive times positive is positive, 3 times 5 is 15. That's the first one. Positive times negative is negative, 3 times 4 is 12. I. Now the next one. Positive times positive is positive. 2 times 5 is 10, since there's an I. Positive times negative is negative. 2 times 4 is 8. I times I is I squared. Combine like terms, since we got rid of parentheses. Here we have the middle terms. Negative 12 plus 10. So 12 is bigger, so the answer is negative. 12 minus 10 is 2i. Note, I cannot have an exponent in the final answer. So you're not done because I has an exponent. So how do we get rid of the exponent? No. You'd think, yes, you'd think, but you can't do a square root, because if you do a square root to that, you have to do a square root to everything. So let's see. Remember what we had earlier? We had square root of negative 4. We said was equal to square root of negative 1 times 4, which equaled square root of negative 1 times square root of 4. Square root of 4 is 2. And then we said that one was I. On the first page. So we know what's this is telling us is I is the same thing as the square root of negative 1. So if I squared I, that means I have to square the other side. The square root and the square cancel. So I squared is equal to negative 1. So anytime you have an I squared, just drop it and change the sign of its coefficient. What this says is 3i squared. Since I squared is negative 1, it becomes negative 3. If we had negative 5i squared, I squared is negative 1. So negative times negative is positive. So just pretty much just drop the I number if it's squared, and just change the sign of the coefficient. That'll save you in calculations. So back in our example, we have an I squared here. So this becomes 15 minus 2i. This changes that sign. Combine like terms. 15 plus 8 is 23 plus I. What if we had this? What do you do first? Distribute, yeah. So multiply this one to everybody inside there. So we have negative times positive is negative. 3 times 3 is 9. I. Negative times positive is negative. 3 times 2 is 6. I times I is I squared. Positive times positive is positive. 5 times 5 is 25. Positive times negative is negative. 5 times 4 is 20. I. Order of operations of do exponents first. So this one changes this sign. So we have negative 9i plus 6 and drop that I squared. Minus 20i. So the real part, 6 plus 25 is 31. Negative 9 minus 20, they're both negative. So 20 plus 9 is 29. I. Do this one, and then I'm going to show you a shortcut for another type of problem. All right, since there's nothing between there, so we know they're multiplying. So we take the first term. Negative times negative is a positive. 3 times 5 is 15. Negative times negative is a positive. 3 times 4 is 12. I. So that finishes this one. Positive times negative is negative. 2 times 5 is 10. I. Positive times negative is negative. 2 times 4 is 8. I times I is I squared. Order of operations, exponents first. We'll do that first. So that just changes that sign. Combine like terms. 15 plus 8 is 23. Positive and negative. 12 is bigger, so it's positive. 12 minus 10 is 2i. There's your answer. Get that? Okay, now I'm going to show you a special type of product with these imaginary numbers. What do you notice about this one? Same numbers, but what? Different signs. We learned this in first part of chapter 2. It's called the difference of two squares. A plus B times A minus B becomes A squared minus B squared. You have the same numbers, but different signs. So the end result is going to be this. Let's prove it. So the first one, 3 positive times positive is positive. 3 times 3 is 9. Positive times negative is negative. 3 times 2 is 6. I. Positive times positive is positive. 2 times 3 is 6. I. Positive times negative is negative. 2 times 2 is 4. I times I is I squared. Notice in the middle, it's the same numbers but different signs. They're gone. There is the example of this proof. Because if we just look at the numbers, we have 3 plus 2, 3 minus 2. Looking at this rule, it is 3 squared minus 2 squared, which is 9 minus 4. That's what we have here. But because it's an imaginary number, what happens with this? It changes that sign. All right, do that one. Right? So we have negative times negative is a positive. 5 times 5 is 25. Negative times negative is positive. 5 times 3 is 15. I. Positive times negative is a negative. 3 times 5 is 15. I. Positive times negative is a negative. 3 times 3 is 9. I times I is I squared. The middle terms are opposite, so they cancel. I squared changes that sign in front of it. Without doing the calculations, tell me what the answer is going to be. Very good. So if you look at these last two, 9 came from 3 times 3. 4 came from 2 times 2. Just add them together because they're imaginary. 5 times 5, 25. 3 times 3, 9. Forget the signs, because whenever you square a number, it becomes positive. 5 times 5 is 25. 2 times 2 is 4, equals 29. That only works with imaginary numbers. If we didn't have imaginary numbers, if we had x's, what would it be? Yeah, because positive times negative is a negative. The only reason this turns to be positive is because I times I is I squared. See, so this one here says if you have two numbers, just different signs in between them, it becomes this. But if b is an imaginary number, you square the imaginary number, you get an I. 5 times 5 is 25. 2 times 2 is 4. X times x is x squared. 5 times 5 is 25. 2 times 2 is 4. I times I is I squared. So it changes that to a positive. So the difference of two squares, if we have imaginary terms, it's called a conjugate. The conjugate is simply change the sign in front of the I term. That's all the conjugate is. So if I gave you 4 plus 5i, what would its conjugate be? All you have to do is just change the sign in front of the I. That's it. What is this conjugate? 3i. You can't forget the I. Because the conjugate is, the whole thing is, notice, it's simply going to be a plus of two terms. No I. Because I times I is I squared, and that makes a positive. So this answer is going to be what? Four squared is 16. So it's 4 squared plus 5 squared. 16 plus 25 is 41. -2 times -2 is +4. Plus -3, +3. 3 times 3 is 9. Because the i's get rid of the negatives. 4 plus 9 is 13. Because if you're going to do the long way, -2 times -2 is +4. Negative times negative is a positive. Negative times positive is a negative. 2 times 3 is 6i. Negative times negative is a positive. 3 times 2 is 6i. Negative times positive is a negative. 3 times 3 is 9. I times I is I squared. This I squared changes that sign. It's just a shortcut. Why did I spend all that time showing you that? Because we'll need it on the next one. Whenever you divide imaginary numbers. We have two types of division problems here. No, actually, we really have four. No, one, 2, 3, 4, 5, 6, 7. There's a whole bunch of them, 7 of them. What if I had 2 plus 3i or 12 plus 3i divided by 3? The denominator in this case is a monomial. Monomial means one term. Whenever you have that, you can split them up. Twelve divided by 3 is 4. 3 cancels a 3, so we have 4 plus I. What if you had a monomial on top and bottom? -6 divided by 3 is -2i. What would this one be? There's no I there. You can't put an I there if it doesn't exist. There's an I there, so it has to carry over. This is the stuff we've been doing all along. 10 divided by 2. That's what we did before we started this stuff. Okay, so if you have a monomial, and it's a constant, separate the numerator. Just break it up into 2 pieces. If the denominator is imaginary, The rule is you cannot have an I in the denominator or on the bottom.
You move it up, just.
No, I said, wait till the end of class. I'll let you take all these pictures you want. Since we have an I on the bottom, multiply both top and bottom by I. Because what is I over I? Anything over itself is one. So all you do is multiplying by one. You're not changing the number, you're just changing the way it looks. So I times 12 is 12I. Positive and positive. 3I times I is 3I squared. 3I times I is 3I squared. Remember, I squared just changes the sign in front of it. So we have 12I minus 3 on top and a negative 3 on the bottom. This negative goes up on top. Because remember, the bottom number can never be negative. So it becomes negative 12I plus 3. Negative times positive is negative. Negative times negative is positive. Since complex numbers are written in this form, we just rearrange them. And there's your final answer. So if you have a monomial on the bottom that has an I, just multiply top and bottom by I and work it out. What if you had this? You can't have I on the bottom. So we have to multiply the top and bottom by I. 4 times I is 4I. 5I times I is 5I squared. I squared changes the sign of its coefficient. And a negative goes on top. Like that. And now what if we had binomials on top and bottom? If you have a binomial complex number in the bottom or on the bottom, what do you think you have to do? What did the conjugate do for us? Anytime we multiplied two conjugates together, look at the numbers. Whenever you multiply two conjugates together, you always have a integer. There's no more i's. Conjugates get rid of imaginary numbers. So multiply top and bottom by the conjugate of the bottom. So if you have a binomial on the bottom, then multiply top and bottom by that conjugate of the bottom, which is going to be what? What is the conjugate of our example? Nope. The conjugate of the bottom number. 5 minus 4. Very good. Because if we change the conjugate to the top number will be an integer, the bottom will still be imaginary. We can't have that. So now you work out both top and bottom separately. Positive times positive is positive. 3 times 5 is 15. Positive times negative is negative. 3 times 4 is 12i. Positive times positive is positive. 2 times 5 is 10i. Positive times negative is negative. 2 times 4 is 8. I times I is I squared. That's the top number. The bottom, we know what it's supposed to be already. We can do it in our heads, I hope. We know it's going to equal 29. 5 squared plus 4 squared. If you don't remember that, then just work it out. 5 times 5 is 25. Positive times negative is negative. 5 times 4 is 20. I. Positive times positive is positive. 4 times 5 is 20. I. Positive times negative is negative. 4 times 4 is 16. I times I is I squared. So these numbers cancel. This number changes that. So on the bottom, we have 25 plus 16. Oop, it's 41. On the top, we have 15. Negative 12 plus 10 is negative 2, because 12 is bigger, so 12 minus 10 is 2i. This I squared changes that sign, so we have plus 8. 15 plus 8 is 23. Minus 2i, so I combine these two. 25 plus 16 is 41. And there's your answer. What do y'all think? Pretty easy. Of course it's easy. Okay, let's start the next section. Section 2.